This is an illustration of a screening tool for detecting and documenting exceptional air quality events that cause the violation of the National Ambient Air Quality Standard. In order for a violation of the standard to be flagged as exceptional, it must meet a series of criteria and steps specified by the exceptional event rule. The first of these criteria is that the event must not be reasonably controllable, such as dust storms and major fires. The next criterion is establishing a clear and causal relationship between the air quality exceedance and the event itself. The third criterion is that the event has actually increased the ambient concentration of PM 2.5 or ozone well above normal levels. And finally, the most stringent criterion states that the exceedance or violation would have not occurred but for the event. The states are required to submit to the EPA appropriate evidence to support the flagging criteria. Based on the submitted evidence, the EPA then decides if the flag is justified. Finding candidate exceptional events is accomplished by browsing the relevant observations. Here, we see the ozone concentration exceedances, denoted by large red circles, in the month of April in 2011. Once a candidate event is found and identified, the exceedance can be reviewed in conjunction with other data sets to establish whether the exceedance was caused by normal levels or if it meets the criteria to be classified as an exceptional event. Displayed in this first layer is the location of ozone concentrations exceeding 75 parts per billion on a given day. On April 12, 2011, we can see that there are ozone exceedances in eastern Kansas. We can select the fire pixel layer and make it visible, displaying it on the map view. The next layer displayed is the fire pixel layer, which gathers NASA satellite data and shows that there are high levels of fire radiation. Again, there is an accumulation of fire radiation in the eastern Kansas region. This image layer from the NASA Aqua satellite shows the smoke originating from the Kansas fires. If we zoom in on the fire region, we can see the presence of smoke in the vicinity of the stations that measured concentrations above the ambient air quality standard. The fires represent the exceptional source over the eastern Kansas region. The causal relationship between the exceedance and the fires is shown by the back trajectories. We see here that the airflow passes through the fire zone prior to arriving at the eastern Kansas stations. The most compelling evidence is contributed by the Navy Aerosol Analysis and Prediction System. This air quality model assimilates the satellite-detected fire locations and smoke optical thickness to predict the three-dimensional smoke concentration downwind from the fires. The highest concentrations of predicted smoke are found in the area of where the Kansas fires were located. The evidence that the measured ozone is well above the normal levels is shown in the ozone anomaly map and time chart. At the monitoring site, the 3-year median ozone concentration is 52 parts per billion. The exceptional sample shows 84 parts per billion, that is, an excess of 32 parts per billion over the normal values. In conclusion, the exceptional event decision support system consists of a wide range of relevant observations and models that characterize the event. The associated software tools are dedicated for preparing the appropriate documentation and evidence. The DSS is implemented through DataFed. States can use the system to identify candidate events and to gather evidence, while the EPA can use the system for evaluating the strength of the submitted evidence.